Good evening, everybody. Hope you're all having a wonderful, wonderful Saturday. Can't really, figure out the days of the week at the moment, apparently. Anyways, we're back with Project Longshot today. A little wonderful game here. So last week we got a little bit of texturing working. Had a little bit of problems reading in the texture. And right now we have this wonderful effect on the side where we're getting like our texture stretched wonderfully. And the solution to that is that we are going to introduce texture coordinates to our shaders and to our program today. And while we're doing that, we're probably also going to add in sort of face normals, which will allow us to do a little bit of lighting calculations, which will hopefully get on towards the end of the stream. We're also going to factor out a little bit of the material code so that we can sort of specify textures and shaders in a config file rather than having them hard-coded in the program, which is going to be especially useful later on as we start to add more and more of these. But first things first is to get our texture coordinates and normals into the program. So if we switch over to the code here, we can get started. So you might remember that the last things that we've done, or last time when we were doing these, we made this vertex buffer for our chunk, which contains all the vertices for every square or every cube. And then when we do a render, we just add the indices of the faces that we actually want to render and transfer those to the GPU, hopefully saving a little bit of time transferring that across. So the annoying thing is that we have to, in addition to vertex data, or for every vertex, in addition to its coordinates, we also need to add normals and texture coordinates. Now the annoying thing here is that if we quickly switch back to our, like for every corner in this model right now, we're using the same vertex no matter what face we're dealing with. So if it's like this front face, it's going to be the same coordinates. If it's the side face, it's the same coordinates. If it's the bottom, which I can't really show you because we can't go up and down yet, it's also going to be the same vertex. But when we add texture coordinates and we add normals, it's going to have to be different vertices because you can't share, or rather all the attributes of a given vertex must be the same. So I can't like say take the normal from this point and take the vertex from this point and this. I could, but it would make life a lot harder and I wouldn't be able to do vertex sharing to the same degree, so we wouldn't really be able to do this in a nice way. So what we're going to have to do is we're going to have to take every vertex and we're going to have to store it 4 times or 6 times, one for each direction. So that's going to be the first thing we do today. So our vertex buffer is currently just a large array of floats, which we have over here, of edges times edges times edges times 4 for the individual x, y, z, and w coordinates. So what we want to do first, and because this is going to get a little bit more complicated, is we're going to define a structure for each vertex. So rather than just having all the floats sort of mumbled together, we're going to give it a little bit of structure so that we can easily add in these other things and we can offset to them. So what we're going to do here is we're going to define a private structure here called vertex data. So it's going to have GL floats for the x, y, z, and w coordinates. It's going to have floats for the texture coordinates, typically the s and t, but it's only 2 coordinates. And then we're going to have a normal on this, which we are going to add in as also a pair. We're going to call this normal x, normal y, normal z, and normal w. So now we have this structure. We're going to use that instead of the actual floats, and then we don't need to multiply by 4. We just have the edges of, or for every vertex, we just have one of these. Now we're going to need to know a couple of sort of steps to these, and so we're going to define a couple of sort of static members here, which will tell us a little bit about the size and the offsets. So what we'd like is offset. This is going to be a size t. Offset texture chords, which is going to be in C++, or C has this wonderful offset of thing, where I can say the offset of in vertex data of the member S, and then that will assign that into it. And then we are going to have an offset of the vertex coordinates, which I'm gonna assume are 0, but I mean, it might be nice to sort of make it explicit. So this is going to be the offset of x, and the normal coordinates are going to be the offset of nx. So now we have these offsets into this structure. Then we can start using it. So we have to populate this. Now before that, we have a lot of these calculations where we sort of index into our vertex buffer here, where we do this calculation. So what I want to do is just quickly split that out so that we don't mess up in it, because it's repeated a hell of a lot of times, and one mistake will really annoy me, as it's going to be incredibly hard to find it. So we are going to add a static function that's going to do vertex indexing. So it's going to be a static function because we don't need to know our instance, we just need static data. So we're going to have this return actually a GL short, because that's what we index with in our index buffer here. So we're going to call this vertex index, and it is going to take, let's see, prefer to represent x, y, and z as size t's, so we're going to take that across. So it's just going to take the x, y, and z, and then it's going to return a vertex index. We also want it to return as size t face, or take a facing direction, because soon we're going to need to know if we're facing up, down, left, right, front, back to index as well. So to do our vertex indexing here, we're going to jump over and implement that. So we have our chunk renderer. It has our new vertex index function that we want to implement. Here we go. So what we're going to do is we're going to grab this calculation here, and that's essentially what we want to do. With the only exception is that we need to add, that's how it works, we need to add the facing as well, so that we can index based on that as well. Not size, but edges. And generally, but initially we're going to keep this as 0, and that will just index normally. So that means that whenever we have this type of an expression, we're going to do a little bit of regular expression magic to substitute that. So what we want to do is we want to capture stuff where we have some expression here. We need to put that in regex mode. So let's just start by getting this working by escaping the special characters. That's special as well. There we go. Now we're capturing that. So here I really want to get pretty much anything. And I want to do that in a capture group so that we can reuse it in a bit. Same thing here and here. Now that matches pretty much everything. So what we want to do is we want to replace that with calling vertex index. instead, and then we're going to use these capture groups to get our variables into it, so that this here with x, y, and z, which is just simple indexing, will become vertex index x, y, z 0, which is what we want. So that it ends up like this. We're going to skip that one because that's the one we just wrote. And this is going to be vertex index x plus 1, y plus 0, z plus 0, and facing 0. Looks like we're capturing a space or a parenthesis that we might not want to catch, but that's going to be really hard to avoid. Yeah, we'll have to work our way back through that and correct it in a moment. Actually, what we could do is just adjust it in this one case. That's going to be a lot of undoing here. And I just, do that as well. I'm going to want you to replace these like that. That's correct. Skip that one, and then here, because we're also sort of pulling off a push back at the beginning, I need to grab that off, and I need to add that, and we're still going to have one parenthesis, two parentheses too many that we're going to need to get rid of. So what we're going to just do is add in that we have like this parenthesis here, and we have a parenthesis at the back here, and hopefully that looks about right. We're going to replace that down through here. And that's all nice and good. Now here we have the thing with vertex data and float are not compatible, because we're doing this weird last indexing where we're looking at the various elements. We don't want to do that anymore, because now we're using this structure, so we can get rid of that. Instead we have .x, .y, .z, and .w that we can just assign to. Much easier. So I would, So with that done, we are also going to need to modify our vertex attribute here, because when we load vertex data in, we're still loading 4, we're still doing it with floats, we're still not normalizing, but the size of a given element is no longer 4 floats, it is now the size of our vertex data. So we can say size of vertex data, and our offset is going to be vertex data colon normal coordinates. No, not the normal coordinates, vertex coordinates. And we get a pointer from integer without a cast, because this is supposed to take a pointer, but when you bind a buffer, it doesn't, and lots of other fun stuff. So what we're going to do is we are just going to have a static cast to a void pointer here. So this integer is now magically a pointer, and that should work. Offset of incomplete type. Great. So problem here is that we're still defining vertex data at the point where we're actually creating these. So perhaps we can just forward declare them. Here. So we're going to do this. So they're not going to be constant time expressions. We're just going to compile time constant expressions, we're just going to have normal constants. So where do we declare all our stuff? Down here. So I want chunk renderer : vertex data vertex coordinates here. Need to declare what the values of all of these are. So again, vertex coordinates are the offset of in our chunk renderer vertex data. We want the offset of x, first of the normal coordinates or the vertex coordinates, and then of normal x and of, I think I mentioned s first. Yes, great. See, that's a little bit better. So now we're getting the cast error. So we're going to have to go with a little bit harder of a definition. So just trust us. Going for the reinterpret cast. The joy of interacting with C from C++. So our chunk, or our definition of the data doesn't match our declaration here anymore. That's the error we're getting down here. And this is sort of the previous definition. So the thing is, we're no longer using GL floats here. We're doing our chunk renderer vertex data. Come on. Oh, still terrible at spelling chunk. Vertex data. And we only need edges times edges of it, no longer the times 4. So let's try and see if that doesn't. Well, it's linking, so that's a good thing. And if we refresh our browser, well, I say nothing has changed, except that our data for our sphere is kind of gone. So yeah, something has changed. Question is what? So facing is generally set at 0, so this will be 0 plus the x plus y. So that looks sane enough. We're getting a vertex back. We are indexing with the same thing here. We're setting x, y, z, w here. So did we get this wrong? Let's have a look. So our GL attribute pointer, I happen to have that open because I kind of had a suspicion we were going to need that. We can switch over. So first, index, which is correct. Second, size, number of components, still 4. Type is still floats. Normalized is still normalized. Stride specifies the byte offset between consecutive generic vertex elements. If stride is 0, the generic vertex elements are understood to be tightly packed in the array. The initial value is 0. So I would go for that. This is the byte size between the start of one and the start of the next. And that's the size of our vertex data. Then finally we have a pointer specifies a pointer to the first component of the generic attribute. The initial value is 0. And then there's the if a non-zero name buffer is bound to the GL array buffer target, which we have. While a generic vertex attribute array is specified, pointer is treated as a byte offset into the buffer object's data store. Also, the buffer object binding, GL array buffer binding, is saved as a generic vertex attribute array client side or index. Now, the interesting question, let's just transition back, is of course that this isn't the actual transfer of the vertex buffer down here. And this is where it's going wrong because I'm transferring size data times a GL float, which is very wrong. We need to transfer the entire vertex data set here. Let's try that instead. And give that another refresh. And now it looks like we have our sphere. So a nice little arrow there, just sneaking in. So that's always good. So with that done, what I'd like to do is I'd like to go back here and see our facing here should not be a size T because that's sort of meaningless. What we want to do is we want to create an enumeration of our facing directions so that we can hopefully sort of make it a little bit simpler to figure out what direction we're facing and make it easier and more readable when we're doing these at face X, Y, Z, positive and negative. Possibly even roll that into one function, which just also takes the facing value. Could be a possibility. We'll look into that. Should be relatively easily doable. So what we're going to do is we're going to create a class enumeration or enumeration class. We'll see whether it's enum name or body expected, which is exactly what we're about to give it. So what we'd like to call this is we'd like to call it a facing. And it still complains, so it's probably enum class because I think that was invalid before, so it's going to be the one they chose to overload. So what we're going to do is we're going to say, so we're actually going to sort of decide on directions here. So X positive, we're going to call east is 0. And just for reference, this is X positive. So if X positive is 0, then west, which will be 1, is going to be X negative. Then we're going to have north, which is going to be our facing direction, which is Z negative. This is a wonderfully natural order to have them in. And then south will be 3 and is going to be Z positive. Finally, up is 4, and this is Y positive. Just forgetting a couple of commas here. And finally, we have down, which is naturally Y negative. So we are going to go for a facing here. Now, function vertex index is not implemented, which is true enough because we're now using, rather than facing, we're going to call it face here. So we're going to have no, that's actually stupid. This should be called direction. So we're going to have a direction that this face is facing. So we're going to take that direction in. Now we can't do this multiplication directly, but we can just static cast this to a size. So that facing becomes that integer value that we've specified. Or rather just keep it as an integer because I really don't care what kind of integer this is. As long as it can hold these 6 values, I'm happy. So now we have this direction. So that means that we are going to have for our, wonder if, so for a int facing, which will be start at 0, and it will go as long as facing is less than 6. We have 6 directions. We are going to add 1 to facing. And then we're going to swap this loop in here. And then we're going to substitute facing instead of the 0 here. And I'm taking direction from integer. So question is, I can't do that, but I could start with the first one, which is east. So we start with direction east. And while facing is less than direction down, I can actually do that. I cannot advance this that easily. But I guess we can always cheat a little bit with the static cast. So what I want to do is I want to cast to direction, I want to cast to integer. So first we cast facing to an integer, we add 1, and cast it back to direction. So now we're going through all the directions. Now, for a given direction, the normal is always going to be the same direction. So we're just quickly going to define our normal based on that. So that's going to be a nice little switch statement. So we're going to go for a GL float, normal x, normal y, normal z, and normal w. Normal w will always be 0. So that one's nice and easy. Then switch based on our facing. Case we are east, we're facing x positive. In this case, direction, and I spelled direction very wrong, direction east. In that case, our normal x is 1. In fact, we are just going to initialize pretty much all of these to 0 initially, because there's only one of them we want to set to 1. Compiler should be able to optimize that out for us. I'm going to break. And some people will hate me for this, but I think it's going to be easier to get an idea of what's going on if we sort of keep this nice and compact. So west, we are going also NX, but it's going to be -1. If we are going north, that was -z. If we are going south, that is +z. If we are going up, it's +y, and if we're going down, it is -y. So again, sort of the reasoning behind these directions, by the way, is that if we start by looking down the -z axis. So when you're sort of spawning in, you're looking towards -z. So we're going to call that north. So -z is north. Then if that's north, on the right side of that, you would find east, which is going to be +x. On the left of that, you're going to find west, which is -x. Behind that, we're having south, which is again going to be +z. And of course, up is +y, and down is -y. So we are going to write that in. So we're just going to duplicate this, and we're array autocomplete. In fact, I am not going to create the normal w because we're just going to assign it down here. So normal x, normal y, normal z, and 0. Then finally, the texture coordinates. Now this is a little bit interesting. Let's see, we're getting a little bit of errors here. Oh yeah, might as well get this corrected as well. So if we're looking at the face x positive, so x positive we agreed was east, so direction east for all of these. Then we have x negative, which is west. So we're just going to set that in as well. I really want to roll all of these into one function, but we'll get to that. So y positive is up. And y negative is down. go. Then we have Z positive, which was south. And finally we have Z negative, which is north. So there we go. Should compile. Yep, and hopefully it still works. Nothing should have changed. Exceptions thrown. See JavaScript console. Well, that's new and interesting.